Hey everyone, I'm Rajitha, working as Assistant Professor of Artificial Intelligence and Data Science Department in SNS College of Technology. Today we're going to see about concept of rationality in AI. This presentation introduces the concept of rationality in AI. Rationality is the foundation of intelligent behavior in AI system. It refers to making decisions that help the agent achieve its goal effectively. Understanding rationality help as design agent that act logically and consistently. In the in this section, we will explore how agent design, how they use knowledge, how they handle uncertainty, and why bounded rationality is important in real world system. What is a rational agent? A rational agent is an AI system that perceives its environment and act to achieve the best possible outcome. It does not act randomly. Instead, it follow clear objective and evaluate each action based on how much it contribute to those objective. Rational agent constantly check the environment, collect data, process option and choose the most beneficial action. Their decision are guided by goals, performance measure, and logical reasoning. This makes them suitable for tasks like planning, prediction, and problem solving. Performance measure define success. Performance measure help an agent understand what success means. First, they define goals such as accuracy, speed, cost, or safety. Second, they help the agent evaluate its action and choose one that improve performance. Third, they maintain consistency. The agent behave in a predictable and organized manner without a proper performance measure. The agent cannot know whether it is progressing or failing. Therefore, designing clear performance metric is one of the most important steps in building an intelligent system. Per subsequence learning from history. The rational agent does not rely only on the current input. It remembers past experience through a percept sequence. This complete history helps the agent understand patterns and relationship in the environment. It improves decision making because earlier event often influence present situation. For example, a robot may remember obstacle it encountered earlier to avoid them later. By learning from past input, the agent becomes more adaptive and accurate, especially in dynamic or changing environment. Knowledge power rationality. Rational decision making becomes stronger when the agent has more knowledge. Knowledge reduces uncertainty because the agent understands the environment. Better knowledge can come from rules created by the programmer or from learning algorithm that extract information from data. The more knowledge the agent has, the more logically and efficiently it can behave. For example, knowing traffic rules help a self-driving car make safe decision. Therefore, knowledge serves as the backbone of rationality and decision making under uncertainty. Real world environment are unpredictable. Agents rarely receive complete information, so they must make decision under uncertainty. To handle this, they use probability to evaluate possible outcomes. They aim to maximize expected utility, choosing the action that offers the greatest um, chance of success. This allows the agent to make reasonable decision even when the data is incomplete or the situation is unexpected. The ability to operate under uncertainty is what makes intelligent system practical for real life applications. Utility based rationality. Utility represent how useful or desirable an outcome is for the agent. The utility based agent compares different outcomes and select the one with the highest utility. This approach helps balance multiple goals such as safety, speed, and efficiency. Utility based rationality allows flexible decision making because the agent is not restricted to a single rule. Instead, it evaluates many possibilities and chooses the most beneficial one. This is widely used in recommendation system, finance, and robotics. Bounded rationality, real world constraint. In agent could make perfect decision, but in reality they face limitations. They include limited time to think, limited memory to store information, and limited processing power. Because of these constraints, the agent cannot always compute the best possible action. Instead, it aims for a good enough decision within the available resources. This is known as bounded rationality. It reflects how real machines and even human make decision in practical situation. Perfect versus imperfect rationality. Perfect rationality assumes unlimited knowledge and resource. Such an agent can always make the best decision, but this is only theoretical. Imperfect rationality, on the other hand, is what real agents follow. They work with limited data, limited computation, and limited time. Their goals is not perfection, but the best possible choice under constraint. Most AI systems today operate using imperfect rationality while still delivering high performance. This makes rationality more realistic and applicable in everyday technology. So these are the key takeaways for uh, concept of rationality, and this is a mind map for rationality in AI. Thank you.